My name is James Mantu. I'll take you through the new libraries that we have for MSAL, the new authentication libraries, specifically for React and for Angular. We'll start by understanding what MSAL is, which is Microsoft Authentication Libraries that we use to gain access to resources protected by our identity platform. And what we have now is a 2.0 version for React and Angular. So I'm going to make a bit of an assumption that the members on this call have actually interacted with our libraries, the earlier ones for 1.0. So if you get lost or if you need some further explanation on anything, you can just let me know, but we'll go with that basic assumption. So what we had was the implicit flow initially, and we're moving towards the auth code flow now. I'll get a bit point that right after this, but the bottom line is auth code is more secure. And with the new security that browsers are putting in place where they're blocking third-party cookies, the implicit flow really won't work, especially if you look at like Safari with its intelligent tracking protection. Implicit flow basically has become untenable. Any questions?
Okay, could you explain a little more why implicit flow will no longer work?
That's what I will do on this screen that we are on now.
Cool.
Yes. So if you look at how this screen works, the thing with the implicit flow is you have your application, you send a request to your authorization service, whether it's Microsoft or whatever it is. You give it your username, your password, your credentials, and then you get your access token back in a browser fragment. Basically, it's part of your URL that comes back with your access token. Now, the challenge with that is your authorization service is a third party. It's not the same as the domain you're currently on. So once you start blocking requests, cross-origin requests to domains which are different from the domain the browser is currently sitting in, then you have a challenge because that request cannot go silently in the background. What we had been doing, we're using hidden iframes to pass the request to the authorization provider. But because of blocking those requests, they cannot happen silently without actual user intervention, which provides for a very bad experience because you'd have to keep on popping up for the user to in again once the token expires. Does it make sense?
So you are saying that because of the course, I thought that Microsoft IDP allows those cores to begin with, right? Because it's coming from the...
If you're on, let's say, a website, I don't know, let's say Google, for example, right?
Right.
And you want to use Microsoft for authentication. The request, your browser is currently on www.google.com. You have to silently pass a request to Microsoft.com.
Right.
Right. So now Microsoft is different from Google, and this is what browsers are currently blocking with intelligent tracking protection.
You're saying the browser is blocking, but
Yes.
Microsoft allows the course though, right? Because
yes,
that's what's supposed to happen.
Exactly. But by default, as Google, Chrome, Safari, as they implement these features, it becomes more of a challenge, forcing us, because the users really don't notice. They just set up a high security level. So you start having a challenge with the application, and the user is one who has blocked cores on their side because they just set up default settings in terms of security.
Hey, this is Manish. Are you talking about like a course issue or a third-party cookie issue here?
Yeah, third-party cookies. Yeah, go ahead,
Okay,
James.
got it. Yeah, sorry for that. I was a little bit confused. Go ahead.
No, it's third-party cookies that are being blocked. So that now has become a challenge with the implicit grant flow. So what we're moving towards now and the rest of the industry is the auth code grant flow. So as you can see in this case, sorry, I'll just go back one step. The way the implicit flow was designed, it does not have refresh tokens that come in. Whenever your token expires, you actually have to make a fresh request through the browser. If you look at the auth code flow as it was designed, you get an access token and you get a refresh token at the same time. So that whenever you want to reauthorize the user, you can use the refresh token to get another access token. So in this case, you're not being forced to go back through hidden iframes or whatever. You actually are calling your token server and getting your fresh token, your fresh access token using the refresh token. This is what we have implemented in MSAL version 2. This is now supported.
I have a question. This is Priyan.
Yes.
So the same issue that you have
Mm-hmm.
mentioned about the
Mm-hmm.
third-party cookies in implicit flow,
Mm-hmm.
it is related to a browser. The same thing can happen in auth code grant flow also, right?
But you'll notice here the request to get our token are being sent to a token server as opposed to you can actually raise a request to your token server through an API call or whatever it is, as opposed to having to load an iframe, which you then use to get your access. So now you're actually calling an API.
So are you saying that the access token request to Azure AD from a browser-based application if they are using auth code grant flow is no longer dependent on the SSO cookie, correct?
Yes.
Okay, makes sense.
Yeah. Okay. So we'll have this PPT available. You can go through the diagram afterwards. I won't get so much into it, but rather I will want to just maybe take a look at the additional risks of the implicit flow, which we're trying to avoid. Like I mentioned, you get your token back in your URL as a fragment of the URL. So we start facing challenges of interception attacks. And then because it's in your browser might actually just save that history. So these are just two additional risks that we found that is forcing the whole industry to move away from the implicit flow. So taking this further, when you talk about
going back to and making sure that we have the closure on this. It is the cookie, it's not the course, because when you are doing the auth code flow, you are still from google.com, the example that you're giving. If I was on google.com, I would still be making the call from google.com to the Microsoft Identity Server in the auth code flow as well. So it's not the course. If the browser was stopping that, you'll be stopped anywhere, right? That doesn't go away. What you're really saying is that now, you're really working to make sure that those two cookies are not shared.
Exactly. The third-party cookies are what the browsers have been working on securing because of tracking.
Thank you.
Yes. So I wanted to take it a step further and look at PKCE, which stands for Proof Key for Code Exchange. And the idea is that when you want an authorization token, when you want a token, you must prove that you're the application that is supposed to have the token. In our mobile apps and most of our SPAs, we've hard coded the credentials. So if someone is able to get access to your authorization, your auth code, they can spoof that to get access codes from your server. So the question becomes, how do we make sure that the person who is making a request for an access code is actually your application and not just some third party who has stolen one of your auth codes and then using the refresh tokens to keep spoofing your application? So what we have here is basically a proof of possession. What we're saying is that when I come and ask you for an access code, I want to know who you are. And how do we do this? When you are raising a request for an auth code, you pass what we call a code challenge, which means that when you come back and ask now for access to a particular resource, you are able to pass me a code challenge and I verify that you are who you are. So they have a verifier and a code challenge. Before I answer, I think I'll use this screen and then you can ask all the questions we'll have after that. So here's the client, send a request to be authorized, and with it you'll pass a code challenge. Basically, it is something that you can use as a SHA-256 or whatever to verify yourself. The authorization server then notes that code challenge and then issues you the authorization code. And then you come and ask for an access token. When you ask for your access token, you have to send me the original code challenge which you sent. So I know that the person asking for this access token is someone who I have already authorized, as opposed to someone who may have actually intercepted my auth code and then is trying to use that to get authorization to my resources. I would stop there if there are any questions.
What's the lifetime of this authorization code?
The auth code, you can define how long you want it to be alive, but mostly because the auth code flow has refresh tokens, your authorization codes will be valid for a very short while, a minute, 5 minutes, and then your refresh tokens will have validities of maybe 24 hours. So you have to keep reauthorizing.
And is
authorization using the refresh tokens?
Yeah, the authorization code is one-time use, or can we use it within that 5 minutes, multiple times?
I need to confirm that. I am not sure.
I don't. Authorization codes, I believe, at this time are not I don't think they're one-time use, but they have a very short expiration. And the MSAL library handles all of this for you. MSAL.js version 2 handles trading the authorization code for the refresh token.
Okay, so that means we can reuse that authorization code within that 5 minutes because it is coming in the URL, just like the implicit flow. It will be reside in your browser history, or maybe if somebody sees that network proxy, they can see that authorization code. And within that 5 minutes, if somebody captures, they can reuse that authorization code, correct?
This is what PKCE helps protect, but I believe so. I'll double check, but
okay.
PKCE helps protect that.
Thank you.
Yes, because the authorization code has gone with a code challenge. So even if I got that authorization code, I will not know what code challenge the application has sent. And the application will have its own logic of generating its code challenge. So this is not a one-time thing like you'd have username and password saved in your application to use across all your installations. This is something that you can have a logic in the application that keeps generating. And then the auth server is able to check the code challenge and validate that it's come from your application.
This is Manish again. So is this something that you configured for your application to support PKCE on Azure AD?
Okay, as was mentioned earlier, is we built all that plumbing into the library. So from your side, there's not much you'd be doing over here. When you register an application, a new application, you just simply add authorization and tell it to support the PKCE. That's all that will be happening from your side when you register your application on the Azure portal.
So does that mean that my application can support my client credentials plus PKCE as well, both at the same time?
Yes, it does.
Okay.
Okay. So
just if you don't mind, I mean, that's just a little bit like diverted based on like different provider. If you go for an example, Okta, they don't they let you choose one or either, like client credential or PKCE. So not sure. Is that something?
I need to reconfirm on the question of
okay, sounds good.
PKCE and client credentials. Because what we have on Azure, you can add different authorizations to your application. So I know you can put in the auth flow with PKCE and at the same time have some support for implicit flow, although we are currently deprecating our support for the implicit flow. If that's what your product is using, it will continue to be supported, but we're trying to discourage new applications coming in with the implicit flow. And we are backward compatible, so you can actually support multiple authorization flows.
Got it. Thank you.
So that was just basically a summary of what we are trying to do and what we have achieved. So I wanted to take a minute just to basically run through how easy it is to create an application. You just need to go onto the portal, you register yourself, register an application. Then because this is React and Angular, we're using Node.js, and I personally am a fan of Visual Studio Code or whatever editor you want to use. So you just sign in onto the portal. You can choose which tenant you're using. If you have multiple tenants, you just select app registrations, put in a name, select the accounts you want to support. I think most people go for in any organization directly and personal accounts. Then you register and that's it. Then you've got a quick start pane where you can download your application and actually get up and running immediately. And I'll take 5 minutes to show you exactly what I mean when I say you can download your first application, your first React application, actually log in and you're able to access Microsoft Graph. So I was just showing that it's pretty simple. If you worked with React, all you have to do is we made it so simple that we'll tell you where to put your client ID, where to put your authority, where to put your redirect URI. And these are values that in the quick starts we've shared with everybody. So what URIs to use and all that. There's very little plumbing to get up and running with your first product and utilize the identity service. This is just for React. This is for Angular. And then once it's configured, you just install, get up and running. If you don't use the quick configuration, these are our libraries. You can just get them directly from npm through npm install. So I'll actually show you one application that I have, which actually followed these steps. And then I guess after that, you'll have more questions to ask. Just to show you what I mean when I say that it's pretty easy to get started. Yeah, I wanted to use this simple example for, I had followed the steps and registered and downloaded. So this is actually a React application on my side. which I downloaded straight from the website. So you just go to the source, you just come to the auth config file, and that's about it. The way I was showing in the example, you can download this and you just have to set up these values. These are my values for my client. The authority is pretty much standard across, and I'm redirecting to localhost 3000, the default port for nodes. For React. So if I was to come to this and actually run that application, sorry. So already did an npm install, so the libraries are there. Then I just say, npm start. And quite easily, I'm able to get my first screen running. I can sign in, whether I use a pop-up or redirect. These steps are already in place for you. I'll try it with a pop-up. Because I'm already signed in on this is my personal PC, it is already able to sign me in, and I will not request my profile information. But yes, if you do this, you can actually get information. You can use Graph to get as much information as you're authorized to access. And it's actually really simple to get started. It takes about just this much. You just have this one the auth config you need to change. It's a different file for Angular, but you're up and running almost immediately in 5 minutes. So there wasn't much else. We'll hear if there are any more questions, but it's really easy to get up and running with your first React or your first Angular application. It'll take you 5-10 minutes maximum. We've hidden all the plumbing. We've made it so that all the heavy lifting is sitting on our side. From your side, it's just a few configurations and you're up and running.
Thank you, James. This is Chen. Quick question. I know typically when MSAL supports Azure AD, it's very streamlined. Is there any difference when we're dealing Azure AD B2C, in this case? Typically when we get onto GitHub, you see, it's smooth sailing with Azure AD, and the second we go to Azure AD B2C, there's always some quirks we have to work around with it. So for this particular one, I'm looking at for React, is that fully supported, or is there something else we have to do if we're dealing with, let's say, auth code per se, like you recommended here?
Thomas, who actually has been driving the React library and also is very familiar with B2C, do you want to comment on that?
Yeah, it is fully supported. Some of the same quirks that you might run into with browser will carry over into React, just due to the fact that the services are implemented slightly differently. But if you do run into any issues, we encourage you to open an issue on our GitHub page. We try to resolve those relatively quickly.
Okay.
Okay, perfect. Thank you.
Hi, it's Rory. The libraries, are they public preview or GA?
Public preview, not yet GA.
And do you have any kind of ETA for GA?
We're looking at it within the next 1 or 2 months, but let me get the date so that I give you actually something concrete, not what we randomly have. Yeah.
Yeah, we certainly like to have them GA sooner than later. The more of you that try them out and give us feedback, the faster that happens.
Hi, James.
Yes.
Could you give a reason why someone would choose the MSAL library over, say, for example, a more generic OIDC Angular library? What are the advantages in going with an MSAL library?
Now, I was going to tell him, as a program manager driving this product, the fact that we've hidden all the plumbing is one reason I would go for it.
Yeah.
It takes me 5 minutes to get up and running if I'm going to use Azure, and it's a properly industry supported product. That would be a good enough reason for me, but someone else can help me.
Yeah. So some of the other reasons, there are some, Azure AD follows OIDC, for example, but there are some nuances with Azure AD that our library, for one, is aware of and helps mitigate. I would say the other reason is that there are some features that we are shipping in Azure AD that the MSAL libraries will support that you probably won't get from a more generic library. So for example, today we support proof of possession for access tokens. If you're not familiar, proof of possession cryptographically binds access tokens to the browser that requested them. So that helps mitigate, for example, token replay if those tokens are exfiltrated from the browser. So that's like a really key security feature, for example, that our first-party Microsoft products are very much want. And we're looking at proof of possession for refresh tokens, and we're looking at other potential security features and enhancements. And you are probably not going to get those from a third-party library, such as the one that you mentioned.
So I have one question related to the access token. Why is access token available on the browser? I mean, it appears to me that's a browser user to system. Only the ID token should be available, not the access token.
Yeah. So in terms of like, why is it stored in local storage, for example?
Well, yeah, I think to begin with, it shouldn't be even available in the browser in the user context, right? In the user context, ID token is the one that user needs. Access token is more for system to system. Like in a client credential flow, it makes sense, but in auth code flow and PKCE flow, that's user to system. Because you could take the access token and just log in. So I just wonder what was the thinking behind to have access token available in the browser context.
Yeah, so this comes down to the difference between authentication and authorization. So your ID token represents the user as logged in, right? Tells you metadata about the user and about their session potentially. Whereas an access token says that as the artifact that the user has granted you authorization to acquire data on their behalf from like a backend service. So Microsoft Graph or your own custom backend API. And access tokens can't be shared between resources. So an access token for Microsoft Graph can't be used to acquire data for your backend web API, for example. And ID tokens are not the appropriate artifact to use there. So just because the user has logged in doesn't mean that they've granted you access to acquire data from Graph, for example. So that's what access tokens help solve, and that's why we expose them, in this case, in the user context, in your single page application, for example. And we help mitigate some of the concerns around proof of possession, for example, is a mitigation to help address concerns around tokens being replayed if they are exfiltrated through cross-site scripting, for example. They're also short-lived, so they're only an hour, that sort of thing.
Thank you. That makes sense.
Thanks, Jason, and thanks, Mani, for bringing this up. So our security team has found one flow with this authorization code grant flow. We have been using this in our organization, and what they are telling is the user is logged in. It's a single page application, and they have the token. The tokens are available in the browser cache, and they can capture this token if they are putting any proxy like a bub tool or a fiddler. And even after the user log out, they can replay this token to the end API and get the response within that 1 hour of time.
Yep.
So what the issue that security team is bringing is, if some malicious actor getting the possession of your machine or your browser, they can grab this token and they can replay this even after the user logs out from the application.
Yep.
Is there any mitigation to that?
Yeah, so it's correct that we don't invalidate access tokens. So they are valid for an hour after they were issued. And that is a known trade-off that we have made. As far as if those tokens are exfiltrated somehow, as you described, so if they're intercepted through man in the middle or they're cross-site scripting, for example, yes, they can be replayed from another machine for the duration of their lifetime. So proof of possession, for example, is one mitigation that we have for that. So proof of possession, like I mentioned, it cryptographically binds the access token to the browser that requested it, so it can't be replayed if it's exfiltrated. It doesn't address the expiration thing, and again, that's just a known trade-off. There's lots of complexity that comes with invalidating access tokens that we've decided not to make. So I would look at proof of possession. That is a feature that is supported in MSAL browser, that if you are concerned about your access tokens being replayed by a bad actor outside the context of the browser that requested them, that is one of the mitigations that we provide for that. And we're always looking at increasing the security of our products all up.
Is this proof
to address these concerns?
Yeah, sorry to interrupt you. So is this proof of possession is only for the code, right? Code but it's not applicable for the access token.
No, it is. So PKCE protects the authorization code, and then proof of possession protects the access token. And then we're also looking at proof of possession for refresh tokens as well.
So
but that hasn't shipped yet.
So are you saying that even though the malicious actor captures the access token, they cannot replay from a different system? They can replay from the same browser, but they cannot replay from a different system. Is that correct?
If they're able to exfiltrate it from like local storage, for example, then correct. They would not be able to replay it from a different browser or different system.
So just to follow up on that, the access token is used to, just like you said, to make API calls like Graph API calls, right? They probably don't have the context of the browser. So in general, I could take an access token, and from the back end, I would make API call to get other data. Or are you saying that this access token actually has something related to the browser and it can never be called outside of the browser?
Correct.
Okay, so you mean if I make an API call, just direct HTTP API call with the access token, it will no longer work. It will only work from the browser where the access token was issued with your possession.
Correct. Yeah. So again, this is only for proof of possession protected access tokens. So this is an opt-in feature, and your backend API that you are using the access tokens for must support decoding and validating these tokens. So again, this is not the default, but yes, in this case, if you have a proof of possession protected, if you enable proof of possession in your middleware, in this case, where you're validating your tokens, and then you opt into proof of possession for the access token that MSAL will acquire for you. If someone were to steal those access tokens from your local storage and then try to use them, they would not work.
Is there any documentation on that?
I believe we have documentation in the GitHub repo about this. So take a look there. I'm not sure if we've documented it on like docs.microsoft.
Okay, so I'm just to make sure that we are in both same page. So are you saying that if we enable this proof of possession for access tokens, then the access token minted from Azure AD will have a signature or a proof that, okay, this access token is the user got it from so-and-so browser. And when he plays that access token to the API, in the API also, they have to go back to Azure AD and check that, okay, this access token came from so-and-so, and is it this request, API request is also coming from the same IP. If that matches, yes, access token is valid. If not,
it doesn't have to go back to Azure AD in this case. It's able to statelessly validate that, but that's the general idea. That's not quite how it works under the hood, but that's the general idea.
So that minted token will have a claim that by validating the claim, we can make sure that this is originating from a valid.
No, that's part of it. I don't want to get too much in the weeds about the implementation details, but that's part of it. Yeah. But again, this is not the default, and this is something you have to opt into.
Sure. Thanks, Jason. So can you?
Yeah, and yeah, I'll follow up with that. Yeah, and if you have more questions, feel free to ask on GitHub.
Thank you.
So does Microsoft provide a API side library to do the validation or proof?
Yeah, I believe our .NET library supports this, basically validating proof of possession. I'll make sure that we have that documented if so.
Hey, Jason, this is Srini here. Is there a documentation where we can refer to all these vulnerabilities and how this feature mitigates some of them and which one it is not mitigated?
Are you talking about proof of possession?
Yes.
Like I said, I'm not sure if we have docs up at the moment for that, but I'll make sure that we do that if we don't.
Because that clarity is really helpful for us who are in the field to help customers understand.
For sure.
Thank you.
I have one more question on the tokens. So in the sample, they have mentioned about getting a token for user.read. Say, for example, if I have multiple tokens acquisitions like SharePoint token, Graph token, CRM token, most of our application will have multiple dependencies like Graph. maybe for getting the signed in user details, or SharePoint API to get the documentation or the content from the SharePoint, or maybe for CRM. So if we have multiple APIs or dependencies, so what is the recommendation from the MSAL perspective? Should we add these scopes like a comma separated one by one and get the tokens on startup itself, or when the user takes an action?
Yeah.
On that.
Okay. Yeah, I understand. Thank you. So our general guidance is that you have there's two operations, right? There's logging in and then there's acquiring tokens. So when you log in, you can provide the scopes that you know that you want your user to consent to upfront, right? So if you have 6 scopes across 3 different resources, you could provide those upfront, and we will prompt the user to consent to those scopes if they haven't consented already. That being said, we only issue 1 access token at a time, and access tokens are only valid for 1 resource. So if you have if you need an access token for SharePoint, you need an access token for your backend API, you have an access token for Graph, for example. You can provide consent for them up front, and we'll issue, I forget exactly what it is, but basically you can provide all of those scopes up front in your login call, so the first call to the authorized endpoint. And then I think we'll issue you an access token for one of those, and then downstream in your code, basically when you need, kind of the general guidance is right before you need an access token for a given set of scopes for a resource, you call acquire token silent, and you provide just the scopes for that resource, and MSAL will acquire an access token for that resource for those scopes. Does that make sense? So you can provide them all up front in the interest of having the user consent, but then when you downstream, you can provide those just on a resource-by-resource basis for each respective API. Each respective API calls, and MSAL will acquire an access token just for that resource for those scopes.
Cool, got it. Thanks.
I think I would also add that since, like we mentioned, we have refresh tokens and we are handling the refreshes. So even if you call early, before you log out or destroy your session, the access remains.
Okay, got it. Another question on the conditional access policy for this authorization code grant flow. So when what we have seen or what we have observed is when we are specifying only the application, like we create a single page application, and when we specify that single page application into the conditional access policy, we are seeing that the policy is not getting applied. And what the workaround that we have seen is we have applied the conditional access policy for the first token that is getting procured. And we are applying the conditional access policy for both single page application and for that API, custom API. So is that the correct way to apply a conditional access policy to a single page application using web authorization flow, or is there any other ways?
I'm personally not sure the answer of that. So you might need to send that question
in
separately.
Sure. Thank you. And what about the ADF support to MSAL 2.0? I mean, with web authorization flow, does support ADFS or only Azure AD?
We should support ADFS. Thomas, do you have anything you can add there?
Yeah, we do support ADFS, but there are changes that you'll need to make to support cores on your ADFS server.
Yeah, are you supporting the ADFS 2016?
Yes.
Is it 2016 or 2019, Thomas? That one of them, there's a specific dependency that you need to have, I think.
Let me double check.
Thank you.
Any more questions?
Hey, can I go back to the third-party cookies again?
Okay.
So are you guys changing anything on the server side? On the cookies saying same site equal to none to Lex, that's what you guys are doing, or because
the same site we've addressed what browsers did was they first rolled out same restrictions around the same site flag on cookies. That was done a year ago, maybe a little more. We did all the work needed for that, and then that was like the first part of like the third-party cookie changes that browsers were rolling out. So we did all the work needed for that, and then browsers are now going a step further where they're just simply blocking third-party cookies in certain contexts. And that's where, the workarounds, the mitigations for that are the MSAL.js version 2 library that uses the auth code flow, where we don't rely on third-party cookies for most silent token acquisition, which is what James described earlier.
So if I have an old app, that will stop working after some time with the implicit flow?
You're using Azure AD Implicit Flow?
Yep.
So yeah, so if you're using Azure AD Implicit Flow, if third-party cookies are allowed, it will continue to work, even with the same site changes that browsers roll out. Now, if the user is in a scenario where third-party cookies are not available, so Safari ITP is enabled or Chrome Incognito, for example, the implicit flow is somewhat broken in that regard. And in that scenario, you can mitigate that by, you can still acquire tokens using the implicit flow, you just have to do it through interaction. So you have to do like acquire token pop-up or
you cannot do behind the scene in iframe. That's what you guys.
Yes, the token acquisition through an iframe is what is broken. So that is what MSAL version 2 helps mitigate, because we no longer use hidden iframes to acquire new access tokens in most scenarios.
Which browser came with this? Like, because Chrome still support lax, none, and strict.
Yeah, so Safari with intelligent tracking protection enabled. That was really the first browser. And then if you do Chrome Incognito, like if you open an Incognito in Chrome, really any of the Chromium browsers, so like the Microsoft Edge and Incognito, you'll see when you open the Incognito window, there's a little toggle at the bottom of the new tab screen that says whether or not third-party cookies are blocked. That is on by default now. So that is another scenario where users would encounter that.
Got it. Thank you.
Are you aware of any technique in MSAL where when the pop-up is displayed that we can make it stay on the top of the screen so that the user can't lose sight of the window?
Yeah, so there's a GitHub issue open about this. We can't prevent I don't believe we can prevent the pop-up from going into the background, but we're looking at ways that we can at least improve that experience. If, for example, if the user thinks that the pop-up is closed, then they click your login button again, that we maybe focus the existing pop-up. We're looking at improvements we can make to that, because we're aware of that issue. So keep an eye on our GitHub and npm for releases, and you can take a look in the change log to see if when we've addressed that. It's definitely something that we're definitely looking to improve the experience, especially around multiple pop-ups.
Steven, I'll hand it back to you to help us close out.
Yes, thank you, James, and thank you, Jason, and everybody else who participated today. I love all the questions and the interaction. So this is really great. We'll post a copy of the PowerPoint that Jason showed today in the description of the video that we're going to be posting on YouTube. So thank you, everyone, for calling in today. We really appreciate it, and we hope to see you on our next call, February 18th. So thank you so much.